Hello guys, welcome to the 1.7 quiz review. Let's go ahead and just start with number one. What is the expected value or average of the raw data below? So with this one, because it's just simply raw data, there's not like any probability with it, or anything like that. I would just calculate it like a regular average. You don't have to go above and beyond to do it a different way than you normally would have. This one's just, do it what's comfortable with you. And if doing it just the regular average way is comfortable, and then that's how we'll do it. So let me kind of move this if I have room for it. So we have 6, plus 3, plus 7, plus 5, plus 2, plus 9, plus 4, plus 8, plus 5, plus 1, plus 5. Let me double check all that. 6, 3, 7, 5, 2, 9, 4, 8, 5, 1, 5. There you go. That's our total. And there are 11 numbers here, so we do need to divide my answer by 11. And we get an average of 5. So the answer here, simple, just 5. So let me go ahead and show my work, though, just because I'm going to post this later. Let me zoom in a little so I can more easily write. So 6 plus 3 plus 7 plus 5 plus 2 plus 9 plus 4 plus 8 plus 5 plus 1 plus 5. All divided by 11. And like I said, that came out to 55 divided by 11, which comes to 5 as an answer. All right, number 2. So with number 2, our table on the right, or our column on the right, is our occurrences, but it's missing something. It's 6 occurrences, yes, overall, but it's still missing something, and that is probability. So you have to think about how many occurrences occur in total here, and if we add these all up, 6 plus 4 plus 7 plus 3, this is 20 occurrences. So this number 100 occurred 6 out of 20 times. The 200 occurred 4 out of 20 times. 300 was 7 out of 20 times, and then the 400 was 3 out of 20 times. So now we're going to use that instead for our relative frequency and math it out that way. So 100 times 6 out of 20. We're going to add this with 200 times 4 out of 20. Add this with 300 times 7 out of 20. And then add that with 400 times 3 out of 20. So assuming I got everything in there right, we get 235. And that feels kind of right, I think. Okay, so 235. Let me show all my work again. So 100 times 6 out of 20 plus 200 times 4 out of 20 plus 300 times 7 out of 20. And then lastly, we go. And this equaled 235 as our answer. All right, sweet. Not a problem. Number 3. Number 3, pretty similar, but what's nice is that these are already probabilities. So we'll just kind of put them in their decimal forms and it'll work out. So 60 times 0.15. We're going to add it with 70 times 0.20 plus 80 times 0.35 plus, I'm not going to have enough room for all these, 90 times 0.25, and then finally 100 times 0.05. So we add these all up, and we'll have our average. So let's see here, 60 times 0.15, plus 70 times 0.2, plus 80 times 0.35, plus 90 times 0.25, and finally add 100 times 0.05. So keep in mind 5% is 0.05, not 0.5. Very easy to forget that extra 0, so be very careful about it. And we end up here with 78.5 as our final answer. All right. So these are all very similar questions, which is nice. If you can do one, you can do them all. And if you don't know, then all you gotta do is learn how to do one, and then you'll learn how to do them all, which is nice. So the sum of probabilities must equal what number? So they must equal the number 1. In a sense, and this is a good example if you look over number 3. See, my probabilities are in decimal form. Well, if I were to add these decimal form probabilities together, like 0.15, 0.2, 0.35, 0.25, and 0.05, if I add just those decimals together, those probabilities, they would come out to equal 1, exactly 1. So that's what probabilities have to add up to is 1. And if it's a percentage, they have to add up to 100%. You can also see that in question number 3 with the actual percentages. The percentages here should all add up to 1, and they do. So that's nice. All right, number 5. What is the expected grade? Okay, so the way I like to modify these is, instead of the percent of the grade, I like to turn into raw numbers. So I like to just keep them as 40, 30, 20, and 10 instead of 40%, 30%, 20%, 10%, just my preference. And then I'll keep the grade for that category as a percentage, and then obviously convert that to decimal. So for tests are 40% of the grade, or 40 points out of 100. And this student here has 75% of those 40 points. And for quizzes, there are 30 points in total. This student has 83% of that category. The student has, we have 20 points for project, and they have 93% for projects. And then lastly, the student has 10 points for graded practice, and he has a 96% with that. So I kind of have to squeeze that last part in, but we're going to go ahead and grab our calculator and throw these numbers together. So I'm just going to stick with the original table. We have 40 times 0.75 plus 30 times 0.83 plus 20 times 0.93. And then we have 10. Oops, I forgot the plus sign. Plus 10 times 0.96. So the student's grade is an 83.1%. There we go. And then finally, number 6. Sammy is deciding whether or not to pay the parking meter when she's going to the movies. She knows that a parking ticket costs $65, and she estimates that there is a 60% chance that the traffic police spot her car and write her a ticket. If she chooses to pay the meter, it will cost $9, and she will have a 0% chance of getting a ticket. How much of a risk is it to not pay the parking meter? All right, so let's look at the outcomes, right? And the probability of each. So one outcome is she gets the ticket and she pays $65 for the ticket. The probability of that happening is a 60% chance if she runs the risks. However, she could just pay the $9 for the meter, and then she'd have a 0% chance of paying a ticket. Or other outcome, she pays nothing. She doesn't pay the meter, doesn't pay a parking ticket because she never got caught, and there's a 40% chance of never getting caught. And this is 40% because if there's a 60% chance that she does get caught, that means there's a 40% chance she doesn't. So calculating all these out, minus 65 times 0.6 plus -9 times 0.0 plus 0 times 0.4. Now, what's kind of interesting to note is that both the second and the third values here are being multiplied by 0. So essentially, they're not going to be really counting for anything. Really, the only math you kind of have to do is this first one. So let me tell you what I'm talking about here. So take -65, times it by 0.6. And we get -$39, right? If you did all three of these together, negative 65 times 0.6 plus 0 times 0. Hold on, no, this was 9. Negative 9, sorry, times 0.0, and then plus 0 times 0.4. It's still negative 39 because negative 9 times, where's my, there it is. Negative 9 times 0 is 0, and 0 times 0.4 is also 0. So these essentially are worth nothing. So I just want to point that out in case you didn't already notice it. But essentially, negative 39 would be the average price that we pay if we don't buy a pay the meter, the parking meter. So we have two options. We can run the risk of paying on average $39 every time we choose not to pay, or we can just pay $9 every time we choose to pay. So I think it's pretty obvious that it is worth paying the meter and not taking the risk. So don't risk it. Pay the meter. There you go. All right, that's going to wrap it up for the 1.7 quiz review. Hope it helps. Yeah, I'll see you guys in class. Best of luck on the quiz. Bye.